Hello everyone, welcome to 1045 Engineering. We are here with yet another video in Grind 75, a better Blind 75 coding series. So let's jump to today's problem. Today's problem is on flood fill. So what we are going to solve is we are given a color which is being represented by a number, and all the numbers adjacent to it must be changed with the same number. So I'll explain the problem statement on Leetcode, but okay, we'll start. So last time we had already completed binary search. It is done. Let's start with flood fill. Okay, so before we start the problem, let's just first quickly go through the problem statement, and then I'll come to the explanation. An image is represented by a matrix m cross n. You can consider this image here. Integer grid image, where image ij represents the pixel value of the image, so ij would actually be representing these values. You are also given three integers, sr, sc, color, so it's like the starting row, starting column, and the color. And they are all in integers. If you see, the color is also in integer. So let's say 1 is representing a color. It's given with the value integer, but it's representing a color. Similarly, 2 is representing a different color, 0 is representing a different color. And SR and SC are the starting points of row and column. So this central box is highlighted, showcasing that this is the starting box for this example. If you see SR1, SC1, 0, 0, 0, 1, 1, 0, 1, 1, right? Okay. You should perform a flood fill on the image starting from the pixel SRSC. To perform flood fill, consider the starting pixel plus any pixel. Okay, so how are we going to perform? Okay, we have to consider the starting pixel, this one, plus any pixel connected 4 directionally to the starting pixel of the same color as the starting pixel. So if you look at its 4 direction, here we have a 1. So 1 and 1 will consider it is of the same color. This 0 is not of the same color. This is 0, so it's not of the same color. And this is 1. So wherever we are matching with the 1, so we have to check in 4 directions. Right, left, up, down. We can see it's matching only in up and left, right? So connected 4 directionally to the starting pixel of the same color as the starting pixel, plus any pixels connected 4 directionally to those pixels also with the same color, and so on. So let's say for this one I went up 1. Now I have to check for this one also in all the 4 possible directions. Up does not exist anything, down we already came from there, left also 1 exists, right also 1 exists. Similarly, we have to do this for this one as well. We have to look up, right, left, down, right? Replace the color of all the aforementioned pixels with color. Okay, so we are given a new color. So in this case, this new color is 2, right? We are given the starting position SRSC 1, 1, so we are here. Now we are going to replace 1 by 2 for all the adjacent 4 possible directions. Okay, not for all the ones, but all the which are attached to it. So that's why the term flood fill. It's like flood is just filling in all the possible directions which are the same, right? Okay, so we have 1 here in the center. Then we check in 4 directions. Down there is a 0, it does not match with us. Right, there is a 0, it does not match with 1. Up, 1 matches with 1, right? So firstly we replace this one with the new color, that is 2. Then we replace the top one again with the new color 2. Similarly, we check the left direction, we replace 1 by 2. Now we replace the above 1 by 2. Now we'll check for its left, right, up, down directions again. So left there is a 1, so 1 is matching our initial color 1, so we replace this 1 by 2. Right side there is a 1, we replace this 1 by 2. Similarly, we go to this left one, we go check up, it is already replaced by 2 here. We replace this by 2, we check down, that is replaced by 2 now. On left side there is nothing. Now for this corner ones, 1, we check up, there is nothing, we check right, there is nothing, we check left, which is already completed, we check down, it's 0. 0 does not match our initial color, that's why 0 is still 0 in our final output as well. Similarly, from this one also we check up, it is already completed. We check left, nothing exists. We check down, nothing exists. We check right. Now 0 does not match our initial number 1 or the initial color. So we do not make any changes with this 0. And similarly 1, we cannot reach 1 from any of the flows, right? It's an easy problem statement. You can consider it is medium level as well, but if you understand it well enough, you can easily implement it. There are several approaches you can take to solve this. You can go with BFS, you can go with DFS. BFS is breadth first search, DFS is depth first search. But in both of these approaches, for this particular case, you are going to arrive at the same time complexity of M and N, plus overall it is not going to make much change anyway. So we are going to solve it with one of the approaches, though I'll make sure that I'll put up the solution with both the approaches in video's information section. Okay, let's start. So first let's collect the old color. So we'll say int old color. Generally though it should be COLOUR, but since they mentioned COLOR, we'll go with COLOR, is equal to image SR SC, right? So the earlier value at the central point, the SRSC that they have given 1 1, right? So whatever value is there already, that is 1, that will become our old color, right? So we can say get the old color from the starting pixel, right? Now similarly we'll just have a quick check. What if old color was already 1 and the new color that comes is also 1? Then we don't need to make any changes, right? Because the color is matching the same color. So we can say if old color. Now you must be thinking, what if this one is 1 but the other one is 0? But if the other one is 0, it does not match the initial color, so anyway we do not have to change. So if the new color is same as the old color, will not change anything, right? So if old color is equal to color, it's given here as a new color, we will simply say return image, right? Image is a array. It is being depicted by an array. Okay, now I'll just put the comments for this as well, so that it's helpful for everyone. No need to perform, right? No need to perform flood fill. Return the original array. Okay, or we'll say return the original image. Image is the array. Now we are going to make a function. Okay, we want to make a function which is actually going to help us in fulfilling this. We are going to call this, since we are going with that depth first search approach for this answer, let's create a function. Okay, first let's create a function, then we'll come to it. So I'll call it depth first search. Okay, function. Let me put the abbreviation as well, DFS. Okay, so this will be I'm now creating a utility function that we will be using and will directly be calling from a flood fill, so that recursively it will fill all the values one by one. Because you see, when we come to 1, we go to next one, we check for this all the 4 directions, then we check for this one's all the 4 directions. So you can see that a recursive approach makes sense here, that we directly call this one, then we call all the 4 directions for this one, then we move to next one, we call all the 4 directions for next one. So hence we'll go with DFS and a recursive approach. Let's create a private void DFS. We don't need any return type return from here. Int image, that is our starting image. Int SR, int SC, starting row and column. Int new color, since now will be available with a new color, that is color, right? And int old color. So old color is actually the starting number here. Okay, now what do we want to check? There are few base cases, so let's cover the base cases so that everyone can understand properly. What would be the first base case? Because you see, it can happen a lot of time that there nothing exists on the left hand side of this one, nothing exists on the top hand side of this one, nothing exists in the bottom side of this one, right? So these will consider as our base cases, because if we are moving out of the array, then we are not going to fill the color in them. So we'll check two base conditions. We'll check if the current pixel is out of bounds, right? Out of bounds. Out of bounds means out of boundaries. Then we'll simply just return. Similarly, we'll also check if the current pixel has a different color. Return. Why different color? Because see, on the right hand side of this one, it has a color of 0 and this one is 1. So we do not flood fill this pixel. We only flood fill the pixels that contain the same color as the old color, and we replace them with the new color. So these are two base conditions. We'll quickly put a if check for them. So if SR, that is starting row, is less than 0, right? Or the SR is also showcasing our rows. So if row pointer is less than 0 or SR is greater than equal to image dot length, because of the, then it will move outside our boundaries, because we cannot have a -1 in the arrays for the rows. Similarly, we cannot have a row beyond 3, 0, 1, 2, so more than 3 or 3 or more than 3, right? Similarly, so we'll put OR condition and we'll check for column as well. If column is less than 0, or if column is greater than equal to image dot length, right? But column is a column comes like this, image first. So this represents that row's length, that becomes the column length. Directly saying image dot length gives us the row length, image 0, that means the first column in this, and that column's complete length gives us the column length. Okay, I know that is very obvious to everyone, but just for the sake. Okay, so if SR, we have checked that the row is within bounds, it's greater than 0, it should be less than the length. Similarly, column should be greater than 0, it should be less than the length. But in case if it isn't, right, then we are just simply going to return. Second check is for the color. So we'll simply check if image SR SC is not equal to old color. We are passing the old color here. Old color is this original color 1. Okay, if any of this case is true, we'll simply return from this function. We are not going to perform anything. Now we are going to change the color of the current pixel, because if none of these conditions are getting met, that means we are in the right place, and now we should replace the color with the new color. So we are at this one, we'll replace it with new color, which is 2, right? So we can say image SR SC is equal to new color. Done. But now we want to do the same for all the adjacent rows and columns. So sorry, all the adjacent neighbors, right? Up, right, left, down. These checks will always come in when we call this method again and again. So this way, that's why we are going to use a recursive approach, and we'll recursively call DFS, right? Our method for all the NEIGHBORING. For a moment I forgot the spelling. All the neighboring pixels, right? Okay. Now there are 4 sides: up, down, left, right. So let's call DFS. We are calling this method again. what are we going to pass? Image, it accepts the image. Then we are going to say SR, that is the row, plus 1, right? We'll pass the same column, we'll pass new color, we'll pass old color. Okay, which direction is it? So we were at SR, we are only increasing the row by 1, we're not changing the column. This is for up direction, up, sorry, we are increasing the row, sorry. So this is for down direction, okay, it will be down. Similarly, we'll call DFS again, image. Now this time we are going to say SR minus 1 SC, wait, SR minus 1 SC, new color, old color, and this is for up direction. Okay, similarly we'll call for the right and left directions as well. So let's call for right direction first. Image, row will remain like this, SC plus 1, so column will move to right side. So we'll check the right hand pixel. We'll pass new color, old color, and this is for right direction. Similarly, last one would be, everyone can guess, image, SR SC minus 1, new color, old color, and this is for left direction. So what happens is, with this we filled it, and now we are calling on each of the 4 directions, up, right, sorry, up, left, right, down. Okay, I'll come to the explanation again. Let's finish it, finish the code here. Okay, now we have created our utility function for DFS, which is going to fill all of this, but now we need to call this function from our main method, right? So we'll simply call DFS. Now we already are aware what DFS does. Image, SR SC, new color, and what is the old color? Old color is just color, right? That is clear to everyone. Oh sorry, we have changed old color, so I can actually call this color. What are we expecting first we are expecting new color, which is color, so we'll say color, and then we are passing old color, so it will be old color. Okay, let me put the comment for everyone. Okay, call the DFS function to start the flood fill. So whenever this is done, we'll simply return our image, because this DFS will recursively call internal DFS methods for all the 4 possible directions, will fill all the colors, and in the end image will be completed to this image, right? Just okay, maybe I'll write this as well, return the modified image. Okay, let's do a dry run quickly. So our starting pixel, starting row is 1, column is 1, so 1 1 we are here, that is passed here, 1 1. Image matrix looks like this, 1 1 1 1 1 0 1 0 1, right? Color, that is our new color, that is passed to us, is 2, right? So we come here and check if old color equal to new color, old color equal to color, no, right? So this loop does not get true, and it does not enter this loop. Then we call a DFS method. We pass the image, we pass row and column values, we pass the new color, the old color. Then we arrive at our flood fill method. This is the method which is actually performing our flood fill. So first we come and check the base conditions. If the row or the column is outside bounds would mean that if the row has reached -1, or it has reached more than the length of the rows, or the column has reached -1, or column has reached more than the length of the rows. So this we are checking here. If row is less than 0, or it is greater than image length, or column is less than 0, or it is greater than image column length. then in that case we are simply going to return from this DFS. Similarly, we are checking if the image, the starting pixel that is passed, so in this case earlier it is 1 1, if image SRSC is not equal to the old color, which is 1, okay, then we'll return. Since all of these conditions are false for this step, since we are at row 1 and column 1, we do not enter to this loop. We come here, we update the image SRSC to new color, so this 1 is updated to 2. Now we call this same method again for the down direction. So we were here, we updated it to color 2. Now we will call it for this down direction. So now our row is 2, column is 1. Okay, now row will become 2, column will become 1. We arrive here, row is 2, column is 1. We'll check, is row less than 0? No. Is row greater than equal to image length? No. Is column less than 0? No. Is column greater than equal to image length? No. Is image SRSC? So SRSC row is 2. So 2 1. So what is the value at 2 1? 0 1 2, 2 and 0 1. 2 1 we have this 0. Is not equal to old color? Old color was 1 and 0 is not equal to 1. So that statement is true. So we simply return from this method. Nothing is done for this value. So nothing changes here. We come back to the previous method. Now we call DFS again for up direction, which is this one, right? Now value of row is 0, value of column is 1. We arrive here. Is row less than 0? No, it is 0, but it is not less than 0. So this is false, this is false, column values are false. Is image SRSC? So 0 1, 0 1 is this one. Not equal to old color was 1. No, they are equal, so that is also false. So we do not enter this loop. We go down and we say image SRSC. So for image 0 1, we will update it with new color. So this pixel here gets updated to color 2, right? Now we are calling DFS on image SR plus 1 and minus 1, all the down, up, right, left direction from this starting pixel, okay, which is now changed to 2. From here we are now calling first for down. It will be checked again, it will not match the old color, it will come back. Then we'll call it for up. It will fail here because it's smaller than 0, it will come up. Then we'll check for left, it will update the value to 2. We'll check for right, it will update the value to 2. Okay, I hope that was understandable, but please let me know in the comment section if it was not clear. Plus I'll also be including the another approach with breadth first search in the video description, so you can take any of the approaches. Overall you are going to achieve the same time complexity. Quickly just run it and check. We didn't run it, we were busy explaining. Sorry, I didn't run it, I was busy explaining. Okay, it's running fine. Let's quickly submit. Okay, yeah, so even if we would have taken the breadth first search approach as well, I think overall time complex, in terms of time complexity, we would have resulted in 99 or 100% of beating the 100% of the users only. And now the time complexity of this overall problem is O of m cross n, where m is the length of rows, n is the length of columns, or you can consider m is the length of columns, n is the length of rows, because we are traversing the complete matrix here. So m cross n will be our overall time complexity. Okay, that's all from today's video. We'll meet you next time. Yes, one quick thing. So we have completed flood fill, we'll mark it done. Yeah, that's all from today's videos, everyone. Thank you. Please like, share and subscribe. Have a great day. Bye bye.